Okay, so we're going to be talking about laws of motion and Sir Isaac Newton and how he came up with the 3 laws of motions. You're going to be taking the notes in your science notebooks or your science folders. You're going to be titling it Laws of Motion in your table of contents, and be sure to include the entire slide in your notes so you have good notes to go back to study for the test. So let's talk about who Sir Isaac Newton really was. He was born in 1643. He studied math, physics, and astronomy, so he was one smart cookie. He discovered that there was 3 laws of motion, and these 3 laws of motion describe how our things move and interact around us. So let's learn more about those 3 laws of motion. The first law of motion states that an object at rest tends to stay at rest. An object in motion tends to stay in motion. So basically, whatever an object's doing, it's going to tend to stay how it's doing unless some outside force acts upon it. So motion cannot change without an unbalanced force acting on it. This first law of motion can also be referred to as the law of inertia. There is a natural tendency of objects to keep doing what they are doing unless that unbalanced force comes in and acts upon it. Objects will resist change in their state of motion, which means they will not change unless an unbalanced force makes it change. An unbalanced force is a force that causes a change in motion of an object. Let's get an example. Example 1. A skater is rolling on a skateboard. The skater hits a rock and falls down. What's the unbalanced force? Well, the unbalanced force would be the rock the skater hit. What is the motion? Well, the skater is going to be moving flat on his face forward. And what happened to the skater? Well, he fell. He fell down because the unbalanced force of the rock caused the movement of the skateboard to stop, which sent the skater flying on his face. Yikes, that sounds like it hurts. Let's look at another example. A driver is driving his car without his seatbelt on. The car hits a brick wall. The driver goes flying out of the car. What's the unbalanced force? Well, the unbalanced force is the brick wall the car hit. What is the motion? Well, the motion will be the car moving forward. What happened to... it says to the skater. It meant to be to the driver, my typo. What happened to the driver? Well, the driver goes flying outside of the car and onto the brick wall or onto the pavement of the road. Yikes, wouldn't want to be him either. So that's just a couple examples of how Newton's first law of motion makes sense and is put into place. Let's look at the second law of motion. The second law of motion says that acceleration is produced when a force acts on a mass. The greater the mass of an object being accelerated, the greater the amount of force needed to accelerate that object. Well, that seems pretty straightforward. Basically, the bigger object you have, the more force you need to move that object. It shows a relationship between force, mass, and acceleration. So if you wanted to calculate force, you would have to times mass times acceleration, and that would give you force, which is measured in newtons or in. Let's look at an example. Example 1. Mike's car, which weighs 1,000 kilograms, is out of gas. Mike is trying to push the car to a gas station. Mike makes the car go 0.05 miles per second. Using Newton's second law, compute how much force Mike is applying to the car. So keep in mind our equation is force equals mass times acceleration. So we just plug in what we know. We know the car weighs 1,000 kilograms. It says 100 with a comma, but it's supposed to be 1,000. That was my typo. And it also says 0.05 seconds is how fast the car goes. So we times 1,000 by 0.05 seconds. The answer you get is 50 newtons. So Mike was basically applying 50 newtons of force on his car based on the acceleration of the car and the mass of the car. Pretty simple. Let's look at the third law of motion. For every action, there is an equal and opposite reaction. So for every force, there is a reaction force that is equal in size but opposite in direction. Whenever an object pushes another object, it gets pushed back in the opposite direction equally hard. Let's look at an example. Let's think about a rocket. The rocket's action is to push down on the ground with the force of its powerful engines. The reaction is that the ground pushes the rocket upward with an equal force. So the action is that the rocket pushes down on the ground to try to move itself up. In reaction, the ground pushes the rocket upward and the rocket shoots off. Blast off. Let's talk about speed. Speed is the distance traveled by an object during a given interval. The average speed equals the total distance traveled divided by the time it took it to travel the distance. So average speed equals total distance divided by time interval. So when asked to calculate the speed, you have to divide the total distance by the amount of time it took. What about instantaneous speed? Well, instantaneous speed is the rate of motion at any given instant. Position must always be described by comparing it to a reference point. Now recall from when we read in our book about reference points. Reference points are saying, like, if the playground is my reference point, and I want to tell you how to get to the school based on the reference point, the playground. I could say take 100 steps to the left from the reference point of the playground, and you would reach the school. That's how you use a reference point to tell your position. Displacement. Displacement is the net change in position of an object. It's described by both distance and direction. If you end up where you started, the displacement is ending up being 0. So if I start at my classroom, I take a walk all the way around to the building, and I come back to my classroom, my displacement would be 0 because I'm ending where I started. Velocity. Velocity is a measure of motion that tells you how fast and which way an object moves its velocity. Average velocity, the measure of how fast an object moved over a certain displacement. Average velocity, to calculate it, you have to take the total displacement and divide that by the time interval. Notice that velocity is the total displacement divided by the time interval rather than the total distance, which is speed. So what is relative velocity? Well, relative velocity is the velocity of one object determined from the view or from a reference of another object. So it's determined by some other perspective or view. Acceleration is at the rate at which velocity is changing, and you can accelerate in two ways. You can accelerate by changing speed, you can accelerate by changing directions, or you can accelerate by doing both. And that's where we're going to end today for our notes. Make sure you have good thorough notes. Feel free to go back, rewatch the video, pause as needed to get a thorough notes in your science notebook.